Let's take a look at how knowing the isotope name really helps me to build a picture of the atom. Our goal is to use the number of neutrons to identify specific isotopes and then be able to use the isotope name to get a complete picture of what that atom looks like. And remember, we're going to try to focus on that mass number. So let's consider the difference between calling something carbon versus carbon-12. In the top picture, all I can see is that it is carbon, and it has 6 electrons, but it's not a clear picture of what's in the nucleus. The bottom picture, carbon-12, tells me more about what's inside the nucleus. Now, since both of these are carbon, I know that that means it has 6 protons. The top picture could be labeled with 6 protons if I wanted it to be. The bottom picture shows those 6 protons. 1, 2, 3, 4, 5, 6. Remember that positive charges are a sign for protons. But that bottom picture also makes it very clear how many neutrons are in the nucleus. The carbon-12 lets me know that there are 6 neutrons as well. 1, 2, 3, 4, 5, 6. And I could know that even without the picture, just from the name. Because we know that all carbons have 6 protons. And we know that this mass number is the number of protons and neutrons, then I can find the number of neutrons by subtraction. 12 protons and neutrons minus the 6 protons means there must be 6 neutrons. Let's take a look at that in another example. If I want to determine the number of neutrons from the mass number, you just do subtraction. The number of neutrons is the mass number minus the number of protons. Here is boron. I'm going to use the name boron 11. And the first thing I want to figure out is how many protons does boron have? Well, boron is element 5 on the periodic table. This is the atomic number. So boron has 5 protons. Now, because in a neutral atom, the number of protons and electrons are the same, I can also say that a neutral atom of boron 11 has 5 electrons. So the last piece is how many neutrons does this atom have? Well, I know it's boron 11. It has 5 protons. The number of neutrons is the mass number minus the number of protons. 11 minus 5. And we're going to get 6 neutrons. In this way, I'm able to get a clear picture of all the subatomic particles, as long as I know the isotope name